answer key is posted on Moodle for this, so if you want to go through things, see what you missed, and if you have questions, feel free to stop by. Happy to go over anything with you in my office. By and large, things went pretty well. Average is in the 80s. So happy with that. We still have 3 more exams, still have a final. If you didn't do as well as you wanted, so have plenty of time to make up scores as we go forward. Still lots of time left in this semester. Improvement always counts for something too. Everybody's allowed a bad day, so one bad day is not that big of a deal. You do well on the other ones. So. All right, so let's talk about some similar stuff to what we were doing right before the exam. We're just going to work in reverse. So these problems, I don't think there's a lot like these in WebAssign. So we'll go through these 6 that I have on this handout before we go into the next section on inverse trig functions. Well, one of the things that you care about trig functions about are doing some modeling types of things. So if you've got some data that is periodic, maybe it's temperature data, maybe it's wave data, like tidal data, or maybe you're trying to model sound or electricity that's in waves. You might want to use a trig function to model it. In order to use a trig function to model it, you need to make sure you have things matched up. Do you have the right amplitude? Do you have the right period? Do you have it shifted the correct way? Okay, so that's what these problems are all about, is trying to figure out if this was your final graph, thinking about it as, from an application standpoint, if you had a set of data, could you figure out what the amplitude piece needs to be? Can you figure out what the period is and those kinds of things? Okay. So that's the whole point of this particular handout, is to be able to work backward, if you will, rather than being given a function and ask the questions about amplitude, an explicit function, and ask those questions. Can you work backward from the data? Now, we're not going to have, honest to goodness data. I'm always going to give you a graph with some points on it. But that's the idea behind this, okay? All right, so this one asks us to fit this to some sort of a sine function. And basically what I have here that I put on the graph is kind of the starting and ending points for a period of the graph, right? So we know that it starts here, ends here, if you will, goes up, down, and back up again. So let's just ask the same kind of questions in the same order that we talked about for if I gave you an explicit function like the problem that was on the exam. Okay. So the first thing is, what's the amplitude? Remember, amplitude is half the distance between high and low, right? So your amplitude always is high minus low over 2, right? It's half the range, if you will. What's the high point on this one? 5, and the low point is 1. So that simplifies to 2. So thinking of this as another way, this is the idea of amplitude. If this is kind of your baseline, the middle of the graph, your amplitude is a measure of how far above and below that baseline your graph goes. Right? So I get an amplitude of 2. Of A, B, C, and D, which number is related to the amplitude? A. As a matter of fact, if it's positive, that A is the value, right? So in this case, your A is 2. Does that make sense? All right, let's do the B next. Let's look at the period. Like I said, I've labeled 2 points on that graph. We go from point 1/3, 3. We go up, down, and back up to the point 7/3, 3. So how long does it take for that graph to repeat? 2, right? And how'd you come up with 2?
I just subtract 7 over 3 minus 1.
Yeah, It starts at 1/3, ends at 7/3. So the difference between those two things will give you your period. Right? So our period here will be the 7/3 minus the 1/3, which is really 2. Good. Of A, B, C, and D, which value relates to the period? B does, right? That's the thing that tells you about the period. Now, for amplitude, we said the amplitude was 2, so the A value was 2. So as the period is 2, is the B value 2? No. In fact, how do you solve for the period when you're given the B value? Well, in fact, it's the other way around. You divide it into 2 pi, right? So we're going to set this equal to 2 pi over b and solve. And so we'll get, if we multiply by b and divide by 2, we'll get b is equal to pi. That makes sense? Yep. Pardon me. Now I need to figure out what the C value is, right? Right. So we know what the B is. The C tells us about shifting, right? Remember how we set that, we solved that before, right? We set it equal to 0 to solve for the C. We kind of have to do that a little bit in reverse. What should you have plugged in here to get the 1/3 out? Should have plugged in 0, right? That should have been at 0, 0 to start with, right? So, pardon me. In this, but what did we plug in? We plugged in 1/3 instead, right? Okay. So the way we'll do this one is we'll still use that same kind of idea, the bx plus c equals 0. We're using 0 here because that's where this point would have been. We might change that number in a different problem. We'll see an example of that later. But instead, we know what b is, it's pi. Instead, we plugged in 1/3 for x, didn't we? Isn't that what we plugged in here as 1/3, not 0? And so if we solve for c now, you get negative pi over 3 for the c value. Again, we may change this number on the right. We'll talk about when we change that number on the right. But we set it equal to 0 because this point where we started should have corresponded to 0, 0. Right? So we set it equal to 0. But instead of plugging in 0, we plugged in 1/3, which is why I replaced the x with 1/3. And we already figured out what the b was. All right, finally, the last thing we need to take care of is the d. What tells you about the d? Your d is a vertical shift up or down, right? Again, that point at 1/3, 3 should be at 0, 0. So how far did it move? Up 3, so the d is 3. Yeah. So this one is the graph just shifted up 3. So d is equal to 3. So your final function with the y equals 2 sine of pi x minus pi over 3 plus 3 would be your final function. Best thing about these problems is you can always check your answer. Plot it into a calculator, graph it, see if it goes through those points. Okay? Let's do the next one. Same idea here. I've labeled 2 points and they're consecutive points for one period, right? If I start down here, you go up and back down and end it, and then it starts to repeat. So that's one period for this again. So let's go through each of the pieces. Just work left to right. So again, how do we find the A?
High minus low divided by 2.
Yeah, high minus low divided by 2. It's the length of the range divided by 2. It's half the range, right? High point is 4. Bottom point is -8. So your amplitude is 4 minus -8 over 2, which gives you 6. So that's your A value. Okay. Period. What is your period in this case? Or how would we find our period? 19 pi over 3 minus 5 pi over 3, right? Because I need to do the length of the interval. Right? Notice that the 4 minus a minus 8 is giving you the length of the y interval. The reason why we divide it by 2 is, again, the amplitude talks about distance from the middle. Right? But period is going to be length of your x interval. What is that? 24 pi over 3 or 8 pi? If I do this, if I simplify that right. And then, so how do we use that number to find the b? Good. Set it equal to 2 pi over b. If we solve for b, we'll get b is 1/4. So you'll multiply by b and then divide by 8 pi. So far, so good? Okay. Now, the shifts are a little bit more difficult in this one than they were in the previous one. The previous one was a little bit easier because if I think about sine graph or cosine graph or what have you, if I stretch it vertically or stretch it horizontally, doesn't matter. Say something like that. Notice the middle stays in the same place, right? So the last one I could just focus on where those middle points were and keep track of where they moved. It's a little bit harder when they're not in the middle, right? So we have to focus on where the points were originally and where they got shifted to, right? Okay. Do you want to work on the phase shift first or the vertical shift first? I think the vertical shift is a little bit easier. Do that one first? Okay. Yes. Okay. Thank you. All right. So let's think about what happened after the amplitude. Remember when we graphed these things, I said always do your stretches before you do your shifts, right? So if we were to take our amplitude and stretch it, instead of going -1 to 1, what would the graph do? Instead of going from -1 to 1, after we did change the amplitude, what would it go to? -6 to 6, right? So how far did it move now? If it was -6 to 6 and then you shifted it, what would your vertical shift be? -2. Yes, down 2, right? Instead of going -6 to 6, it's -8 to 4, right? Because it's shifted down 2. Okay? So notice I have to think about what the amplitude change is and then the vertical shift. Okay? So you have to consider the amplitude first. So after the amplitude change, graph is shifted down 2. So your D is -2. Does that make sense what I'm saying? We went from -1 to 1 to -6 to 6 and then 4 to -8. We stretched it and then shifted it. All right, what about phase shift? Well, notice that these points are in different spots again, right? So I got to think, but those shifts would have happened after we did the period change. So probably the easiest way to think about it, doesn't matter which one we concentrate on, by the way. Your original graph looks like this, roughly. And then there'd be another one over here. Let's focus on a bottom point. Let me focus on this one right here. Original sine graph. Original y equals sine of x. What should be the coordinates of that low point be right there? Well, what's the y coordinate for sure? What's the lowest it gets to? -1. Where does that happen? 3 pi over 2, right? For sine? Right? Okay. So if I think about matching this point up with this one, if I think about matching this low point up here with this point up here, like we did before. We set it equal to 0 last time because that middle point should have been at 0, 0. This low point here should be at 3 pi over 2. Right? So what we'll do is we'll set this equal to 3 pi over 2. But what should we plug in for x? Instead of plugging in 3 pi over 2, what have we plugged in? (19 pi over 3, right? Again, trying to correspond this bottom point here with this bottom point here. Instead of plugging in 3 pi over 3 pi over 2, we've plugged in 19 pi over 3. And we figured out the b was 1/4. Right? So what is that? 19 pi over 12 plus c equals 3 pi over 2. Over 12, that's 18 pi over 12. If I multiply it by 6 over 6, subtract your 19 pi over 12 over, you should get a negative pi over 12. So then your final function then should be a was 6, your b was 1/4, your c is pi over 12, and your d was -2. Notice I used the right point here and matched them up. What else could I have done instead? I could have matched the left points up, right? Do the exact same idea. You should get the same numbers. I could do if I know what the coordinates are, I can do the top point. Yep. I wasn't given those coordinates, so I had to go find them. But yeah, you could absolutely do the top point. Or if you know where the middle point is, you can do that one too. Okay. Oops. This should be negative pi over 2, -1, right? Negative pi over 2 would be where it bottoms out the first time on the left. Right? You could do 1/4 times -5 pi over 3 plus c equals negative pi over 2. That's -5 pi over 12 plus c equals negative pi over 2. Negative pi over 2 would be -6 pi over 12. Add your 5 pi over 12 over it, you get the same value. You should get the same value. Otherwise, something is going completely wrong. You could also, if you wanted to, mix match these things. What I mean by that is, you could have matched this bottom point with that one, if you wanted to. You could have matched this bottom point with that one. It will change your C's, but it'll change your C by a multiple of 2 pi, or add or subtract a multiple of 2 pi to it. And the reason why it would be a multiple of 2 pi is because that's your period for your original function. You know, it repeats every so often. Questions on that one? Again, like I said, these are nice problems because you can always check your answers. Yes. As long as you're, like I said, as long as you get an add or subtract a multiple of 2 pi, it's the same thing. So it won't matter. Yeah. So in this case, I had one below the x-axis on the left, or excuse me, yeah, I had one bottom out point just to the left of the y-axis, and one on the right. So that was how I matched them. But if you match them a different way, you might get a difference. But again, that's okay. As long as you do the process correctly, it'll just be. It looks like it's a different C, but really all it does is just shift it one period over, and it plops it on the same graph. So that's okay. So there is more than one right answer to these. Answer your question. Yeah. Okay. Good. It was very, very long-winded. Sorry. Other questions on that one? The process is exactly the same if you change the functions. Just got to pay attention to what we're looking at and where they should have been. So let's look at cosine. Again, how do we find amplitude when we look at? And distance from the midpoint to the top, or high minus low over 2, either or, right? Where is the midpoint in this case? Where's the middle? -1, right? So how far up and how far down does it go below that -1? A fourth, right? Or you could see that it's -3/4 minus -3/4 minus a -5/4. Right? Either way. So your amplitude here will be what? A quarter. Good. And that'll be your A value. Everybody see that? Yeah, sure. If you look at the middle's at -1, and so we've gone up 1/4. Or you could do -3/4 minus -5/4. That's where we bottomed out here. And then over 2. And so you'd have a half over 2, which gives you a quarter as well. You can do it that way too. Either way works. How about your period? How long is the period? It's where it bottomed out right here. So if I look at my scale, that's a full unit, that's a half a unit, and that's halfway. That's where I'm making it. What's the period in this case? Pi over 2. How'd you find it? Good. I agree with you. So 3/4 minus a quarter will give you a half, so you get pi over 2. Is that the b value? What do we need to do to solve for the b value? Good. So multiply both sides by b, multiply both sides by 2 over pi, and you'll get 4 for b. That okay? Let's look at, now let's do the vertical shift. Is everybody okay with identifying if this is the middle? The -1 is in the middle? Do we see that? Well, then what's the vertical shift then? If the middle is at -1, everything got moved. The middle's at -1, everything got moved. Down 1, yeah. So what's the D value? -1. Remember, if you can identify the middle, the middle does not change with an amplitude or a period change, right? The middle doesn't change until you start shifting things, okay? So if you can identify that the middle is at -1, then the middle must have moved from 0 to -1. So it went down 1. The other way to think about it would be that your amplitude was a quarter. So originally this point would have been at a quarter, and you moved it down to -3/4. So that'd be -1. The phase shift again. Oops. We need to make an identification of where a point should have been and where it ended up. This is cosine now, not sine, right? This is the top right here. That's the top of a cosine graph, right? Right there. Tell me an x value where the cosine graph tops out. 0, right? It tops out it's at the point 0, 1, isn't it? That's a spot where the cosine graph tops out. So I set this equal to 0. What did we plug in instead of 0? Pi over 4. And the b value is 4. So we'll get our c as -pi in that case. So your final function here would be 1/4 cosine of 4x minus pi minus 1. I like these problems. I think they're more fun than doing the other way around. Plus, these are more practical. If you can do it this way, then you can start modeling things. That's the whole point. Well, the whole point for people who actually want to do applications of math. If you don't want to do applications of math, you don't really care. But it is kind of the whole point. I mean, if you're a science person, the whole reason why you're doing this is to apply the math to the science. Right? This is what you would do. How often in science is somebody going to say to you, here's the function, go find whatever its period is? No. It's going to be like, here's a bunch of data, figure out how to model this data using a function so you can actually analyze it in some meaningful way. Yeah, it's always the reverse problem, which is usually harder, but that's typically what you do in science. Or you're going to say, there's a computer program that's going to do this for me. I'm going to put the data in there and let it spit out the answer. No, I don't think about it. Or not. Or you could just not care. That's okay too. All right. Work on the next one for a minute with the cosine, and then we'll do an example with a tangent. So do the cosine one. That's on there. And we'll chat about it. Ready to chat about it? What did you come up with for the amplitude? 4? And how'd you come up with 4? Yep, good. Yeah, the top is at 5, the bottom is at -3, and then did half of that and got 4. And so which value does that give you? The A, good. Yep, that's the A value, right? We okay with that for the amplitude? Okay. How about the period? What did you get for the period? Good. Yep. We got 4 as well? Yeah? How'd you come up with it?
I subtracted 7 over 2, or, yeah, 7 over 2 minus -1.
Good. And the 7 over 2 minus a -1/2, right? The difference between those two x values. 8/2 is 4. Is that the B? What do you have to do?
4 equals 2 pi over b.
2 pi over B. Somebody, did you have a question? Or is it you're just going to say how to do it? Okay, yeah. Yeah, the 4 is 2 pi over B, and so your B is pi over 2. Okay. Agreed. Okay. Any questions on those two at all? So for amplitude, again, we're doing a top minus a bottom. Have to have it because it's it needs to be distance from the middle. And then period, we're doing a right minus left, and then we have to use our 2 pi over b formula to figure out what b is. Is that okay? Since the amplitude is 4, where is the middle? For the y's, where's the middle going to be? 2. I think it's 2. It's going to be 4 up and 4 down, right? So it's going to be at 1, right? So instead of the middle being at 0, the middle is now at 1. So what does that mean your D is? +1. Good. Yep. So your vertical shift is 1 up. So your D is 1. Yes. It's up 1, yeah. Because the middle should have been at 0. The middle value now is at 1. We went up 1. Because the amplitude is 4. So 1 is halfway in between 5 and -3. So the vertical shift is up 1. Or think of it another way. Your amplitude changed to 4. So instead of going -1 to 1, it went from -4 to 4. But now the high point's at 5. So it had to go up 1. All right, so how did you figure out what the C value is? Which point did you look at to help you figure out what the C value is? Yeah, go ahead.
Originally, I used -1/2 pi.
Okay, so looking at that point, that high point there, yeah.
I had pi over 2 times -1/2 equals, or plus c equals 1 pi to
Okay, so remember this has to be the x coordinate, and I think you put in the y.
Okay.
Yeah, so this needs to be the x value that we would have plugged in. Where would this high point have started at for cosine? At 0, 1, right here on the x-axis. So I need to put a 0 there. Yep. So C is positive pi over 4 when we solve. So then our function becomes 4 cosine of pi over 2x plus pi over 4, and then plus 1.
That was 0.
So if I think about my original cosine graph, looks like that. This point is the coordinates 0, 1. And since I'm working inside the function, I need to work with the x's. This is where it would have been. This is where it ended up. So when I plug in -1/2, I should be getting out 0 to match them up. So I'm just trying to match up where it started and where it ended. That one okay? Want to do it one tangent? Or want to do one with tangent? If I could talk and actually enunciate the words. Notice, remember, we don't define anything with an amplitude for tangent because it goes off to minus infinity to infinity. You could still have to figure out an A value, but on any of the ones that I'm going to give you, I'm not going to make you figure out an A value. I just want you to figure out the B, the C, and the D. We're not going to change any vertical scale at all. Okay. Let's do the D first. I don't think that's too hard. At least I hope it's not too hard. D is vertical shift. The point that I labeled should have been where? It's a tangent graph. That point that I labeled should have been where? 0, 0, right? And now it's at a height of 2. So what's your D value? 2. Good. Yeah. This point should have been right there, right? What I have it drawn. So that should have been a y coordinate of 0. It's moved to a y coordinate of 2. So your D should be 2. All right. So let's do B and C. And just like we had before, let's do the B first and then the C. B again corresponds to the period. What pieces of information are you going to use on this graph to help you figure out the period? The asymptotes, right? Each asymptote from one to the next represents one period for the tangent, right? So in this case, our period will be 13 pi over 12 minus a negative 5 pi over 12. That gives you 18 pi over 12, which simplifies to 3 pi over 2. Is that the B value? No. For tangent, what do we use to help us figure out the period? It's not 2 pi over B, it's pi over B, right? Because the original period starts at pi, and so you should get your B is 2/3. And I want to do the exact same idea that we've done in the previous 4 problems we've done. I just need to figure out what the right-hand side of this equation should be. Again, looking at the x value. Instead of the x value being pi over 3, what should the x value have been? Still 0, right? Still like it was for the vertical shift. So we'll set this equal to 0. We plugged in pi over 3 instead. And so if I solve for C, I should get negative 2 pi over 9. So your graph is a tangent of 2/3 x minus 2 pi over 9, and then plus 2 at the end. Same process, we just have a slightly different graph to help us figure out what the values are. What the what is it? Oh yeah, I'll always tell you what the function is. You could, yeah. If I told you to do cotangent, you have to flip it upside down and figure it out. That's more than what I would expect you to do. Yeah, that's harder than what I would want you to do. You can do it.
I was going to find it on accident.
Yeah. Yeah, no, I will tell you what function to do it. Yeah. That one okay? All right. All right, you tell me how to do this last one to finish up this stuff here. You tell me what I need to do. Okay, well, what is the vertical shift in this case? Okay, good. So our vertical shift is down 1, so your D is -1. Everybody see that? Yeah? Okay. Because again, the point that I've labeled here is kind of in the middle of the tangent, so it should have gone through the origin there, the way I have it written. All right, what next? Okay, and how would we do that in this case?
3, 5, 4, 9,
3, yeah. And we get
1.
good.
Divided by pi.
Okay. It should just be pi. Good. Yeah. So we do the 3/4 minus 1/4. That should be consecutive middle points, right? The middle point on that branch of the tangent function, the middle point of the very next one to the right. So that should be representing one period. Do that right minus the left there. Then get 1. So your pi over b is 1. And your b is pi. Last thing.
Find the shift by putting in -1/4 for x. So I times -1/4 plus c 0.
Okay. And why did you use 0 again?
That's where it should be.
That's where it should be, right? It should be at the x equal to 0. And so your c is positive pi over 4. So your final function that would be tangent. Wow, that was a funky looking tangent. Tangent of pi x plus pi over 4 minus 1. That okay? And when I give you one of these, it's going to look just like one of these, right? It's going to be different than that. All right. Anyway, that was a good fun day. All right. So next time we'll get into doing inverse trig function, which is I'm combining two of the sections of the book. One is 5.5 and one is 6.4. So if you're paying attention to the book at all, what we'll be going over is kind of an amalgam of those two sections together. So anyway, we'll see you on Wednesday. Have a good one.